Howdy, my name is Victoria Rios,
And my name is Jan Zuku.
and today we are going to be going over supernode analysis. To understand supernode analysis, we must first understand what nodal analysis is. Nodal analysis is a mathematical method for calculating the voltage distribution between the nodes of a circuit. This is a direct application of Kirchhoff's current law that states that the algebraic sum of currents entering and exiting a node must be equal to zero. Supernode analysis is a nodal analysis technique that is used to solve a circuit that contains a voltage source without a resistor in series. In the first example, we can see that we have two current sources, three resistors, and a voltage source. The voltage source that is in between A and B does not have a resistor in series. Now, there are multiple ways that this circuit could be solved. However, by using nodal analysis with a supernode, we will be able to simplify the mathematical equations that can be used. In the second example, we have three resistors, two voltage sources, and a current source. We can also use supernode, as you can see that at node A and node B, that voltage source does not have a resistor in series. Similarly, in example 3, where we have four resistors and two voltage sources, the voltage source in between node A and B does not have a resistor in series. These three examples show a clear indication of when it may be best to use a supernode analysis technique.
And now we'll go over an example of supernode analysis. Here we have a circuit that has two voltage source, one of 3 volt and the other one is 10 volt, and we have one current source of 4 amps. We also have three different resistors of 1 ohms, 2 ohms, and 5 ohms. Our first step to solve a circuit using supernode analysis will be to identify and label the principal nodes and the ground. Here we can see that we have one node located at A, we'll call that VA, and another one located at B, we'll call that node VB. And we can put the ground as the bottom wire right here. Our next step will be to find the relationship between the two nodes, which in this case we have VA and VB. Here we know that the voltage difference between VA and VB will be equals to 10 volts. So we can write the relationship equation to be VA minus VB is equal to 10 volts. That will be equation 1. And our next step will be to apply KCL at all nodes, or at the supernode. In this case, will be this one here. We know that KCL tells us that the current going in is equal to the current going out. So we can write our current. Let's assume this current here is going out from the node, as well as this one here, as well as this one here, to make it easier for us, as well as this one here. And we can tell from here that I1, I4 will be equals to 4 amps, which is the current going through this loop here. So for the current going in is equal to the current going out, we have 0. There's no current going inside of the nodes. But for the current going out, we have I1 plus I2 plus I3 plus I4, which we know is 4 amps. And now we can use Ohm's law that states that current is equal to voltage over resistance. For I1, we have a voltage of VA minus 3 volts minus 0, which is ground, over the resistance of 1 ohms. And we can do the same for I2. We'll have VA minus 0 over 2. For I3, we'll have VB minus 0 over 5. And we have I4, which is 4 amps. Now we can simplify this to reduce the fraction. At first, we can separate these terms into individual terms. We have VA minus 3 plus VA over 2 plus VB over 5 plus 4 amps. We can remove the term to avoid any mistakes. We know is equal to 0. And to simplify the fractions, we can multiply by 10. By multiplying by 10, we have 10 VA minus 30 plus 5 VA plus 2 VB plus 40. And now we can simplify this to be 15 VA plus 2 VB is equal to negative 10. And now we have our equation 2. And now we remember from equation 1 that VA minus VB is equal to 10. Therefore, VA is equal to 10 minus plus VB. So we can substitute VA in this equation. So we have 15 times 10 and VB plus 2 VB is equal to negative 10. That's simplified to VB minus 10. And that gives us a value of VB is equal to negative 160 over 17, which is equal to negative 9.4117 volts. And now that we have solved VB, we can plug this back into this equation to solve for VA. That will give us a value for VA of positive 0.588 volts. And to check our answer, we can use what we find for VA and VB to plug it back into the relationship equation to make sure that our work is correct. That will give us VA is equal to negative 0.588 minus VB, which is equal to negative 8.47. And that will give us hopefully a value of 10. And yes, indeed, that will give us a value of 10. So this is how you solve a circuit using supernode analysis. Thank you and gig 'em.